We are Team 5 in ME452. We're going through the analysis and redesign of an electric drill. My name is Daniel Forsyth.
My name is Hanan Aziz.
I am Andrew Spagnolo.
My name is Holton Liu.
Hello, my name is Travis Cunningham.
And
Get
let's
into
take
it
a look
now.
at the part.
A cordless drill is a common tool that is used by many people, from people working on basic home improvement projects to professionals. The drill is used for drilling holes in material, as well as screwing and unscrewing screws or bolts. It is important for the drill to have good battery life, be easily portable, and be rugged enough to withstand abuse over many years. Primary customers would be tradesmen, manufacturing workers, and project managers. The secondary customers for the product would be homeowners who utilize drills regularly for repair or individuals who enjoy DIY projects. We expect an annual demand of 1 million units, with 150,000 produced. The core function of the cordless drill is to fasten or drill. The key functional requirements are to deliver power, meaning it must store energy and then transfer the power. It must be able to generate rotation, where energy will be converted, allowing the tool to rotate. It must have controls that allow the user to operate it, which include a speed adjuster and a direction adjuster. The drill must be able to assure safety by protecting the user when in use. It must please senses by improving ergonomics that not only make it comfortable to use but also pleasing to look at. The last functional requirement is to attach components to ensure the drill works as intended.
Now let's take a look at the assembly sequences. So there are two proposals for assembly that will be displayed using the fishbone diagram. For the first diagram, we begin with the transmission and motor. It is then followed up with the right housing, drill chuck assembly, and the left housing. Next, the trigger and shifting switch is attached, followed by the top switch housing. Lastly, the top switch, battery pack, and top switch mount is attached to finish the assembly. For the second assembly, we start with the right housing, then install the internal components in sequence. The motor is attached to the transmission, which connects to the drill's chuck assembly using chuck screws. Next, the top switch is assembled by attaching the cover and switch mount. The shifting switch and trigger are then installed. After the internal components are secured, the left housing is attached using housing screws. Finally, the battery and its mount are installed at the base of the drill.
Next, we will take a look at the sequence comparison table, where we see sequence 2 is preferred to sequence 1 because it has a higher rating in each of the criterion, except for ease of transferring and handling, where it was determined both sequences sufficiently meet the criteria, hence both receiving a score of 2. Taking a look at our functional mapping matrix, we can see that we have a pretty integral architecture with our product, as most of our functions have several components associated with them. We can see this with the function to protect the user, which is shared between the right and left housings, the top switch housing, and the top back panel. On the contrary, one of the functions that is modular is to provide power, which is associated with the battery pack. Moving on to the exploded view of bill of materials, we can see exactly which part goes with each name we have assigned them. This also helps with understanding the function of each part by the name tied to them and how the assembly of the drill can happen.
Now, following the quad chart shows if components have high and low importance, as well as if they have high or low cost. This is beneficial for deciding which of our components are in need of DfM and which components should be considered for elimination to lower assembly cost. My fault. This slide shows our bill of materials, which includes both injection molded and machine components. For materials, we assumed ABS, plastic, and steel for many parts. ABS was chosen for its low cost, strength, and compatibility with injection molding. Steel was selected for its high durability and because it is a common material utilized for screws. For context, black plus Decker electric drills typically range from $50 to over $100. Our estimated total unit cost is at the low end, just $53.38.
From our functional analysis, we looked at the needs of our customers. Our primary customers, people who use drills a lot, have the same functional requirements as the secondary customers, people who don't use drills as much or for heavy-duty applications. As a result, the only function that is different between groups is the store energy requirement, which is solely based on the external battery pack. The battery pack will be made in two variants to satisfy the needs of both customer bases. This slide shows the two variants attached to the drill. The larger battery pack is on the left and the smaller one is on the right for primary and secondary customers, respectively. These batteries are able to interface with the drill with two channels on each component that slide together to constrain them. A spring-loaded latch on the battery ensures that this mate is secure, and by pushing a button on the battery, the constraint is released and the battery is able to be removed. The assembly sequence for the original design can be reordered with the variant parts by being assembled last. This allows us to linearize the assembly process, delaying product differentiation. Thank you.